is called mean hashing. So mean hashing uses Jaccard similarity, which is vectors similarity vectors for usually binary values or data of binary type. And then we will see how we can construct signatures based on that. So Jaccard similarity, as I mentioned, is good for evaluating binary values, or if we're using documents of text, it would be whether they contain this character or this word, or whether they not contain it. And that's why this binary representation is appropriate in this case. So Jaccard similarity of two sets is the size of their intersection divided by the size of their union. And by size we mean the cardinality or the number of elements in the set. So we have two sets of items. The intersection is the number of items that the two sets have in common, the number of items that appear in both the sets. And the union is pretty much the combination of the items in both sets together. So when we divide the number of items that happen in both of them and the number of items that happen in either one or the other one, then that will give us the Jaccard similarity between those two sets. So it really only examines whether they match or they don't match. So we have two sets here. This circle is the first set, and it contains those items that are inside the circle. And the second set is the second circle, and again contains the items that are inside the circle. Now the circles are intersecting. The number of elements that are in both of the sets is 3. 1, 2, 3. So 3 is intersection. The number of elements that is in either one or the other set is all of them. So 1, 2, 3, 4, 5, 6, 7, 8. That's the union. So Jaccard similarity between these sets will be 3 over 8, according to that formula. We can think of them as two vectors. So if we think of them as two vectors, then we look at first one is 0, 1, 1, 0, 1, 0, and the second one is 1, 0, 1, 0, 1, 1. We can have, if we're to compare those two, there are only 4 combinations of zeros and ones that exist. So the first combination is type A, which means both of them are 0. Type B, so these are rows of type A. B will be one is 0, the other one is 1. C is 1 is 1, the other one is 0. and D is that both of them are ones. So the Jaccard coefficient will use this measure, and that is if, let's say, if these two are, this is column 1 and column 2, let's say this is customer 1 and customer 2, and these are some descriptions of the customers. So if we are to compare them, let's say that is the first attribute, then they differ. One has 0, one has 1, so the Jaccard coefficient will for this type. In the second attribute, again they differ. First one has a 1, the second one has a 0. That is Jaccard coefficient of type C in this case. The third attribute, both of them have a 1, so they are the same on this attribute. In the fourth attribute, both of them have a 0, so they are the same. And so on. So basically we are computing the number of attribute values on which these customers have the same description, or if they differ on their description, and that allows us to tell how similar is one customer from the other customer. So the rows we can consider them elements of the universal set. So these are all the elements under consideration for this similarity calculation. The columns are the sets, or these are the descriptions of our objects. So the similarity of the column is the Jaccard similarity of the sets. Which have the row equal to 1. So if we do a column similarity, then with this example, we will count the number of rows which have their similarity equal to 1. So that's that one and that one. Out of 5, we have 2 of them like that. So then the similarity is between those two. C1 and C2 would be equal to 2 over 5, or 0.4. So that's what that is. So those are the ones that have a both have a 1. If we consider the columns that the rows, so that's a row of type D. If we consider rows of type B and C, where it's either 0, 1 or 1, 0, then we will see that we have 1, 2, 3 of those. We are to compute similarity based on this type of rows, then what we will do is so in this case I started with 0, but in here we started with 1. Doesn't make any difference. Here A is 1, 1. And D is 0, 0, 0. So if A is a total number of rows of type A, which means both of them have a 1, then the similarity is A divided by A plus B plus C. So B and C are the types of one is a 1, the other one is 0, or the first one is 0 and the second one is a 1. This formula does not consider the rows that both of them have a 0 in. So with min hashing, what we're going to do is create a permutation of the row. This is just random permutation, and then we will define min hash function for this permutation, which is we will look for the row that happens to have a number 1. So each row will get a number 1, 2, 3, 4, 5. We will look for the first one, then we'll look for the second one, then for the third one, in the order in which they happen in this random permutation.